Good morning, students. This video is going to define about the electronic mail security module number 2 in networks and cyber security. This video is going to explain about the secured MIME messages and the content types. Let me discuss in detail. The overview of this video, we are going to understand about the secured multi-purpose internet mail extension messages and the content type which have been used in the secured MIME, which are going to be called as an enveloped data, signed data, clear signed data, registration request and certificate only messages. Let us discuss in detail about the secured MIME messages. A secured MIME messages makes use of a number of new MIME content types which are going to be described in the next slide. And all of the new application types which is going to be use the destinations packets. This refers PKCS and this refers to a set of public key cryptographic specifications which are going to be issued by the RSA laboratories and made available for the secured MIME effort. We are going to examine this in turn after the first of the general procedure of an secured MIME message preparations. Let us see about the secured MIME content types. It's consisting of two types. One is going to be multi-part and next one is going to be application and has a subtype of 6 signed in multi-part and 5 in applications. PKCS7 MIME, PKCS7 MIME and PKCS7 signature. 4 of them are MIME, one is going to be for the signature. Let us going to see about this. SIME prime parameters are signed data, enveloped data, degenerate signed data, compressed data and signed data. If you're going to see about the descriptions, which is going to say that the signed data is nothing but a clear signed message in two parts. One is going to be the message and other is going to be a signature. And the signed data, which is going to be an signed as MIME entity. Enveloped data is nothing but an encrypted MIME entity. Degenerative signed data is nothing but which contains a public key certificate, and decompressed or compressed data is going to be a compressed entity of a secured MIME. And the signed alone data which is having a signature support of a multi-part or a signed message. Let us discuss about the content type one by one. So if you're going to see about the signature or securing an MIME entity, the SMIME secures an MIME entity with an signature, encryption or both. And multipurpose mail extension entity may be an entire message. If the MIME content type is a multi-part, then a MIME entity is one or more of the subparts of the messages. Hence, the MIME entity is going to be prepared according to the normal rules for MIME message preparation. Then, the MIME entity according to the normal rules for the MIME message preparation, the entity plus some secured related data such as algorithm, identifiers and certificates are processed by the secured MIME to produce which is known as a PKCS object. A PKCS object is then treated as a message content and wrapped in MIME, which is going to provide appropriate MIME headers. So this process should become clear as we look at specific objects and which provides the examples. In all these cases, what happened? The message to be sent is converted to a canonical form. In particular, for a given type and subtype, the appropriate canonical form is used for the message content. For a multi-part message, the appropriate canonical form is used for each subpart. So, the use of transfer encoding requires a special attention. For most cases, the results of applying the security algorithm will be to produce an object that is partially or totally represented in arbitrary binary data. This will then be wrapped in an outer MIME message and transfer encoding can be applied at this point. Typically, it's going to be in radius 64. In the case of a multi-part signed message, the message content in one of the subpart is unchanged by the secured process. Unless what happened, the content of a 7-bit, it should be transferred encoded using an radius 64 or coded printable, so that there is no danger of altering the content to which the signed or a signature was applied. So let us discuss about this content types in detail. We have a range of content types as enveloped data, signed data, clear signed data, registration request, certificate only message. Let us discuss one by one. First one, enveloped data. An application which consisting of an PKCS7 MIME subtype is used for one of the 4 categories of secured MIME processing, each with an unique SMIME type parameter. In all cases, the resultant entity is represented in a form known as basic encoding rules, BER, basic encoding rules. So which is defined in an ITUT recommendations, which represented in the IEEE format 209. So the basic encoding rule format consisting of an arbitrary octet strings, that is therefore a binary data. Such an object should be transferred encoded with base 64 in the outer MIME message. So an example, if you're going to see the steps for preparing an envelope data at an MIME entities are: first one, generate a pseudo-random session key for a particular symmetric encryption algorithm, which may be an RC2 of 40 bits or a triple DES with 128 bit of case. A second step, for each receptant, encrypt the session key with the receptant's public RSA key. As well, for each receptant, prepare a block known as receptant information, receptant info, that contains the identifier of the receptant's public key certificate, an identifier of the algorithm which is used to encrypt the session key, and the encrypted session key. And the fourth step, encrypt the message content with the session key. So the receptant information block follows by the encrypted content, which constitutes the enveloped data. This information is then encoded into a base 64. So let us see a small sample message which includes the header. So the content type is going to be an application of main type and a subtype of PKCS7 MIME, which consisting of a secured MIME type called as enveloped data, along with a name which is going to be secured MIME.p7m. And if you're going to see about the content transfer encoding, which is going to use a base 64 radix 64 encoding process, and the content disposition is going to be attachment, a file number which is going to be mentioned over there. So the content may be present like this. So to recover the encrypted message, the receptant first strips off the base 64 encoding technique, then the receptant's private key is going to be used to recover the session key. Finally, the message content is going to be decrypted with the session key.